Hello folks, so welcome back to the Astrophone channel and thanks for tuning in. In this particular video we're going to discuss what is the best mono camera for astrophotography. So without further ado, let's get into the video. So first I will get into why you should consider using a mono camera for your astrophotography hobby. I mean, didn't we get rid of all of those black and white cameras in the 1960s already? And then I will show you some interesting mono cameras that are available on the astrophotography market today. But as always, I would highly encourage you to do your own research as well. So our human eyes are able to distinguish the wonderful colors in the visible part of the light spectrum that are transmitted at different wavelengths. And I'm talking about astronomical objects here. But cameras, however, they need a little bit of help in the form of filters that can be placed in front of a camera sensor. So camera filters are designed to accept or reject photons that are traveling at different wavelengths. For instance, a blue photon is traveling in between the 450 and the 485 nanometer range. Consequently, a blue filter will pass only those photons that are traveling within the 450 to 485 nanometer range, while rejecting all of the photons traveling at different wavelengths. So you're sure that when you're using a blue filter, only blue light passes the blue filter and it will get registered on your camera sensor. So many astrophotographers like myself start their astrophotography hobby using a DSLR color camera. And these DSLR cameras, they use a Bayer filter. This Bayer filter consists of red, green and blue filters that sit in front of your camera sensor. And more specifically, they have arrays, 2x2 arrays of 1 red, 2 green and 1 blue filter that sit in front of 4 specific capturing wells. And those 4 capturing wells in your camera sensor are able to produce one overall digital pixel, which is part of your digital image. And note that there is an overrepresentation of green filters, so there are twice as many green filters as compared to red and blue filters. That is because our human eyes are physiologically more sensitive to green light, and we want pictures to resemble actually the images that we can also observe with our human eyes. Question of the day: what kind of mono camera are you considering to buy or did you buy for your astrophotography hobby? Let me know in the comment section down below so we can get into a conversation. So what mono camera are you considering to buy or did you buy for your astrophotography hobby? Let me know! So let me give you 3 specific reasons why you should want to consider using a mono camera for your astrophotography hobby rather than using a color camera. Let's get into a little thought experiment here. Let's imagine that we are a blue photon and we have traveled for thousands of light years and finally we are hitting your telescope and we get refracted or reflected onto your camera. Now, when you use a color camera, we are then confronted with a Bayer matrix. And as I said before, a Bayer matrix consists of red, green and blue filters. So only in case when we as a blue photon, when we hit that blue filter, we can pass that blue filter and we will get registered by the camera sensor. But when we are hitting a green or a red filter, we will simply not get registered. We will get rejected by your color camera. Now let's compare this to using a mono camera. When you use a mono camera and when you use a blue filter that sits in front of your mono camera, we as a blue photon, we will always pass that filter and we can actually land anywhere on the camera sensor and we will always get registered. Hi folks, if you like this video, please consider to give this video a thumbs up and please consider subscribing to my channel for more content on astrophotography. Thank you. So this is a recent picture I took of the Copernicus crater on the moon. And a second reason why you should consider a mono camera is that a mono camera is better at narrowband imaging. So narrowband imaging is this very specific form of astrophotography where we try to capture specific elements that are present within a deep sky object. The most famous examples are that there are a lot of nebulae in our Milky Way and a lot of those nebulae contain ionized hydrogen particles. And those hydrogen particles, they emit light at a very specific wavelength of 656 nanometers, and that falls within the red part of the light spectrum. As an amateur astrophotographer, you can then use narrowband filters, for instance an H-alpha filter, to specifically catch light that travels at the 656 nanometer wavelength, whereas blocking light that travels at different wavelengths. So now let's consider a mono camera. So when you use a mono camera in combination with your H-alpha filter, whenever a photon that travels at the 656 nanometer wavelength hits your H-alpha filter, the filter will simply pass that photon and it can land anywhere on the sensor of your mono camera and it will get registered. Now compare this to a color camera. So you put your H-alpha filter in front of your color camera, it will pass the ionized hydrogen particles, but then this photon will be confronted with a Bayer matrix as well. Now, because the 656 nanometer wavelength lies within the red part of the light spectrum, only when that photon hits a red filter in the Bayer matrix will it get registered. As the pattern consists out of one red, two green and one blue filter, you only have about 25% chance that that photon will actually hit a red filter and will get registered on your color camera sensor. So a third reason to use a mono camera rather than a color camera has to do with quantum efficiency. Quantum efficiency refers to the ability of your camera to turn an analog signal into a digital signal. So photons of light, they fall on your camera sensor and your camera sensor is able to convert that analog light into a digital signal, into electrons that are actually registered on your digital image. And of course you want that efficiency to be as high as possible. So if your quantum efficiency is 100%, that basically means that every photon of light, every analog photon is converted into a digital signal. And when we actually compare color cameras versus mono cameras that are similar in terms of brand and in terms of type, then often the mono camera, due to its design, is a bit higher in quantum efficiency as compared to that same color camera. So let's look at some awesome mono cameras that are on the astrophotography market today. But just before doing so, I want to emphasize that I always use different requirements when looking for a good planetary camera versus when looking for a deep sky astrophotography camera. I have a different video where I go into detail about the differences between planetary imaging and deep sky astrophotography and how this translates into these criteria you can see here in this slide. I will put a link in the video description below if you are interested and you can check that video out. But for now, I just quickly want to run through the criteria that I'm going to talk about. So for planetary mono cameras, I will look for cameras that have a relatively high frame rate per second. You're going to take multi-minute videos of the bright planets that are within our own solar system, and the higher your frame rate per second is, the more images you can take in a video basically. So also uncooled camera is actually fine because you're going to take short exposures, so you don't necessarily need a camera that has cooling for planetary imaging. Also, you don't necessarily need a camera that has a high resolution, so low resolution is fine. Already, if you have a 1 or 2 megapixel camera, you are able to capture the planets in our own solar system basically. In this video, we're going to look at mono cameras, and I'm always looking for cameras that have a low read noise, a high quantum efficiency, and a high dynamic range. So for deep sky astrophotography, it's a little bit different. I would say frame rate per second is not important whatsoever because you're going to take multi-minute images of deep sky astrophotography objects. On the other hand, I would prefer a camera that has cooling because your camera sensor tends to heat up when you take multi-minute exposures of deep sky objects. So when you have a cooled camera, this really helps you to cool down your camera sensor, and that reduces the noise that you would otherwise get in your pictures. I would also look for a camera that has a high resolution because some of the deep sky objects, they are pretty large in size. Think about the Andromeda Galaxy or the Horsehead Nebula, and when you have a higher resolution, this basically means that you can capture a bigger part of the night sky. I will often also look for a low read noise, a high quantum efficiency, and a high dynamic range. So let's look at some interesting mono cameras that are on the astrophotography market today. And for that I will be using my own website, astroformspace.com/ZWO, when you want to get to this ZWO camera comparison table. In general, feel free to visit my website, astroformspace.com. You can read my latest blogs, and I have information on how to get started with astrophotography, some interesting gear reviews of course, and tutorials as well. So feel free to visit my website. I always look at the comments, and I will also, you can get into a conversation via my website as well. So for now I have been focusing on developing this ZWO camera comparison table. Of course there are other brands out there, huh? So you have QHI, Altair and other related brands. So I always advise you to do your own research. But for now let's focus on mono cameras, because we have been talking about mono cameras in this video. So let's select mono cameras, and also first let's focus on uncooled cameras, because for planetary imaging you don't necessarily need cooling, and we can discuss the cooled mono cameras in the later section of this video. I don't want to make it too long, so let's dive right in. You can see that ZWO has 7 different cameras available, mono cameras available on the astrophotography market that are uncooled, ranging from about $150 to $700 US. So there's quite a bit of price range here. And I just want to point out that some versions also have a mini version. So you can see here, for instance, that the 290 mono also has a 290 mini version. So what does this actually mean? So this is the 290 mini version you can buy, and you can actually see that the design is a little bit different as compared to a regular. This is the regular version of the 290. And basically these 290 minis, they are more geared towards use with your guide scope. So they are more guide cameras that can be used in combination with a guide scope to guide your equatorial mount. And most of us will then also use PHD2 guiding. I don't want to get into guiding too much, but I just want to make you aware of this fact. So the minis are more geared towards guiding, whereas the regular cameras are more geared towards planetary imaging. But actually when you look at the specifications, they are almost similar. So just wanted to get it out there. And let's just first focus on like the resolution and the pixel size of all of those cameras. Because I made the statement earlier that you don't necessarily need a high resolution and a high megapixel camera in order to engage in planetary imaging. And I just want to prove this point by showing you this particular picture here. So in this picture you can see that I have focused on Jupiter. And I just calculated the field of view you would be getting when you would be using this camera in combination with a telescope, a Celestron C8, which has a focal length of about 2000 millimeters. Then you can see if you use a C8 in combination with a ZWO 120 or a ZWO 290 mono camera, these cameras, they are 1 and 2 megapixels in size. They're already quite sufficient to capture Jupiter, but actually also all the other planets in our own solar system. You will get them clearly within your field of view. So you can see the 178 offers a little bit of a wider field of view, and the 174 offers an even wider field of view. You can see it here. And then the 183 mono offers the widest field of view. But yeah, just to make the point that you don't need to buy the most expensive camera here to actually engage in planetary imaging. So yeah, let's move on to another thing. So I also mentioned frame rates per second here. And just note here that the frame rates per second, you can also sort on frame rates per second, of course. Note that FPS is based on the maximum resolution. So for instance, the 183 has the lowest frame rate per second here, but this is at a resolution of 5496 by 3672. And there is software out there like SharpCap, which allows you to reduce the resolution. And when you reduce the resolution of a camera, of course the frame rate per second will go up. But anyway, this being said, you can clearly see that there's one particular camera, the ZWO ASI 290, which has a frame rate per second of 170. So that's a very interesting camera to look for if you want like a high frame rate per second. It's pretty important when you engage in planetary imaging, because the higher the FPS is, the more images you can take of a planet within a particular time. So you're going to take videos of planets like Jupiter, 1 or 2 minute videos, and when you have a frame rate of FPS of 170, it allows you to take 170 pictures per second, and yeah, you will end up with a lot of images you can use in post-processing basically. So I would say the 290 is a clear winner, and you can also see that the ASI 174 also has a pretty fast frame rate per second at a resolution of 1936 by 1216. So let's move on a little bit and look at the read noise. Well, actually for read noise, they are, I would say, the ZWO 120 MC, so the cheapest cameras, they have a little bit of a higher read noise, and also the 174 as compared to all of the other cameras that are in this comparison table. In terms of quantum efficiency, you don't see a lot of differences. You can see, yeah, is this the 120 again? Yeah, so the 120 has a quantum efficiency of 75%, whereas the 183, so the most expensive camera in the comparison table, has a quantum efficiency of 84%. But we're basically ranging in between the 75 and the 84% range here. Yeah, finally looking at full well capacity, you can see that there's one, the 174, which has a full well capacity that is about twice as much or even 3 times as much as compared to the other cameras. And a full well capacity, I would say, is especially important for, yeah, maybe more important for deep sky astrophotography, because you are able to collect more electrons before the capturing well of your camera sensor is full. So this basically prevents bright objects from becoming oversaturated in your picture. And when we are looking at analog to digital converters, you can see that only the ZWO178 has a 14-bit analog to digital converter. The rest of the cameras have a 12-bit ADC. And yeah, actually ADC means that you will have a higher dynamic range. So you have more points in between the completely black point and the completely white point of your picture. Yes, so let's move on to also discussing the cooled cameras, the cooled mono cameras of ZWO that are on the astrophotography market. I would say these cameras are perfectly suited for deep sky astrophotography, but you can see that there are quite a lot of differences. So we end up with 7 cameras, and the price range, it ranges from $999 to $3,999. So it is worthwhile to take a look at the specifics of all of these cameras. And the first thing you'll notice is that you have some specific similar types, but you sometimes have, for instance, the ASI 1600 Mono without anything behind its name, but you also have the 1600 Mono with Pro behind its name, and you have the ASI 1600 GT. So let me just quickly explain what these differences mean, because all these cameras, they have the same sensor basically. But the first difference is between the regular version and the Pro version. Well, the difference is that the Pro versions of ZWO cameras, they all have here this DDR memory, so internal memory on board the camera, 256 megabytes. And I would say you want to choose a camera that has this internal memory, because what happens is you will take multi-minute pictures of your deep sky astrophotography object. The camera will then first store that picture into your internal memory on board the camera itself, and then it will transfer the data via USB to your PC or laptop. Yeah, when you do not have this internal memory, sometimes you get a degradation in quality of your image because of low transfer speeds of your USB cable, especially when you run a pretty long cable, whereas this is not the case when there's internal memory on board. So that's the first thing, though, the difference between a regular and a Pro camera. Then you have also a difference between a Pro camera and GT. And GT just basically means that you will end up with a camera that also includes a filter wheel that is on board the camera. So here, this is a GT version of the 183 and the 1600 GT. You can see that these cameras, they have a 5-position filter wheel inside, so you can, it's really interesting. You end up with a very compact camera with a filter wheel inside, an electronic filter wheel you can use for your astrophotography. If you buy a regular 1600 in this case, or a regular pro camera, it will look like this, and it doesn't include a filter wheel or any filters or anything. You have to buy that separately. So enough about those different types. Let's move on to also discussing the resolution and the pixel size and the megapixels here. So I have this picture now the deep sky of a deep sky object, in this case the Orion Nebula you can see here, and the Running Man Nebula. And yeah, you can really clearly see that there are differences in the field of view you will be getting. In this case, I selected a refractor, an 80mm refractor with a focal length of 480mm. Then you can clearly see that when you buy the 183 Mono Pro, you will get the smallest field of view basically. It will fit the Orion Nebula, but the 1600 Mono Pro and the 294 Mono Pro, or the GT versions, they are similar. They will provide you with a wider field of view. So with the 1600 and the 294 you can capture the Orion Nebula, but also the Running Man Nebula that is quite close to the Orion Nebula. And yeah, then we have this beast, the ASI 6200 Mono Pro. You can capture about twice the field of view with this camera as compared to all of the other cameras. But yeah, take into account this camera is also, I think, 3 times more expensive, or 2 times more expensive basically, depending on the camera. It's the $3,999 US. So okay, let's move on to also discussing the read noise and the quantum efficiency here. So frame rate per second is actually not so important, so we will skip that for deep sky astrophotography. When we look at read noise, there are not a lot of differences. All of the cameras offer a pretty good low read noise. Of course, they are CMOS cameras, and yeah, so not a lot of differences there actually. When we look at quantum efficiency, you can see that there's one clear difference, I would say. So you can see the ASI Mono versions. I actually have an ASI 1600 Mono camera myself, and these Mono cameras, they report a quantum efficiency of about 60%. And this is pretty low if you compare this to all of the other cameras that are on the market of ZWO. So the other cameras have at least a quantum efficiency of 80% to even 90%. And yeah, keep in mind that quantum efficiency relates to the ability of your camera to convert all the photons, all the light, actually analog light that falls on the camera sensor, into a digital signal. So it ends up in your picture as it gets registered as light in your picture. So you want to have the quantum efficiency has to be as high as possible here. So clearly the 1600 Mono Pro offers a lower quantum efficiency as compared to the other cameras, and the 90% is, actually from the 294 Mono Pro. Offers the highest quantum efficiency here. So that stands out. And when we look at full well capacity then yeah, this is also interesting. So a lot of the cameras, they vary in full well capacity between the 15,000 and the 20,000 K. But then we have the most expensive camera at, here, it's actually 51K full well capacity. But the winner here is the 294 Mono Pro, 66K full well capacity. And yeah, remember, the full well capacity is important because especially in deep sky astrophotography, you will have a lot of variation in between very bright objects. So think about very large, bright stars in your picture. And you might also end up with sections of that picture that are pretty dark. So maybe some nebula that emits a little bit of light, but not too much. And what you want is a picture where that that large bright star is not becoming oversaturated when you take multi-minute exposures. And a full well capacity that is higher really helps preventing this saturation from taking place. So actually I'm surprised that the 294 here has a 51K full well capacity. And then also, of course, we can also look at the analog to digital converter. And then again, most cameras offer a 12-bit analog to digital converter, but the 492 offers actually, and here we are, offers actually a 14-bit converter. So remember, ADC is basically it relates to dynamic range. So you get a higher dynamic range when your analog to digital converter has a higher bit here. And of course the 16-bit analog to digital converter is from the ZWO ASI 6200, so the most expensive camera of ZWO on the astrophotography market today. So, should you use a mono camera or a color camera for your astrophotography? I get this question at least a couple of times every month on YouTube and on Instagram. And my answer is always, it depends on your personal situation. So as I pointed out, there are a couple of advantages and disadvantages of doing both. So when using a color camera, you have to realize that it takes less time and it is less complex to capture and process your astrophotography images. Also, you don't need any additional filters or a filter wheel to engage in your astrophotography hobby. So I would say when you just start out astrophotography, you're still learning how to set up and use your equipment. Start using a color camera first, and when you are a little bit further along in the hobby, I would strongly recommend you also try a mono camera because it offers some particular advantages as well. So with a mono camera you can more efficiently capture specific parts of the light spectrum using your different filters, and you can also effectively engage in what is called narrowband imaging, where you try to capture specific elements that are present within deep sky objects. And although capturing and post-processing takes more time, when you actually master these steps, you are able to produce very high quality pictures of the night sky. So we're at the end of the video. I hope you liked it. If you did, please consider giving this video a thumbs up, and please consider subscribing to my channel by clicking on the button on the bottom right of the screen. I highly appreciate that, and of course I hope to see you again in one of my other videos, and until then I want to wish you clear skies. Bye bye.